You may have heard of the Fibonacci numbers before. It's a sequence which starts off with 1 and 1. Then, to get the next number, you add the previous two numbers together. In this case, 1 plus 1 gives 2. For the next number again, you add up the previous two numbers. So 1 plus 2 gives 3. 2 plus 3 gives 5. 3 plus 5 gives 8, 13, 21, 34, 55, 89, 144, 233, 377, and so on. This repeats on infinitely, with the next number being the sum of the previous two. These numbers are the Fibonacci numbers. You can create such a sequence on any spreadsheet like Microsoft Excel, for example. By starting off with 1 and 1 in the first two rows, and using the sum formula to get the next row, you can copy and paste that formula down into the rows below it. The numbers will be the Fibonacci numbers. Now just suppose you want to know what the 100th Fibonacci number is. Well, technically, you could just use the spreadsheet, right? No, because the cell will display an inaccurate number with not enough detail. So you may be wondering whether or not there's a formula for the nth Fibonacci number. Well, there is. Here it is. Try plugging in 100 for n and see what you get. The weird p is known as phi, or more commonly, the golden ratio. Don't worry if you don't understand that yet. It will be explained later on in the video. Now, do you know what the spiral is? The spiral is known as Fibonacci spiral. This can be created by drawing these quarter circles with a radius of 1, 1, 2, 3, 5, 8, 13, 21, 34, 55, and so on forever. Well, basically, the radius of the quarter circle is the Fibonacci numbers. Doesn't it look nice? Well, the Fibonacci spiral is famous for its appearances in nature, including the examples here. There also seems to be a relationship between the Fibonacci spiral and the proportions of a human face. We investigate this later in the video. Now, let's move on to my favorite part of the Fibonacci numbers, the golden ratio, phi. Discovered in 1597, the golden ratio has fascinated mathematicians due to its beauty and appearance in things like geometry to the human body. But in this video, I've came here to explain the mathematical beauty of phi. Well, first of all, what exactly is the golden ratio? Well, the golden ratio is the approaching ratio of two infinitely large consecutive Fibonacci numbers. Let's draw up a table. For example, the first pair of Fibonacci numbers is 1 and 1, which gives a ratio of 1. The next pair is 2 and 1, which gives a ratio of 2. 3 and 2 gives 1.5, 5 and 3 gives 1.667, and so on. Repeating this infinitely, the ratio will approach what is known as the golden ratio, which is approximately 1.618. Using our already made spreadsheet, we can generate an approximate value used for the golden ratio. By using the division sign in our formula, we can copy and paste that formula down to get the ratio. To further explain the settling down, we can create a line graph to show the bouncing around of the values. As you can see, it starts bouncing around up and down, where it slowly settles down on one specific value, the golden ratio. Now, if you really needed or wanted to know the exact value of phi, there's a formula for it. Phi is equal to 1 plus root 5 all divided by 2. This is why root 5 appeared in the nth Fibonacci number formula, because phi is full of 5. Don't believe me? Let me show you. Did you know that the ratio between uv and xy in this pentagonal diagram is the golden ratio? Or did you know that phi can be written as the square root of 5 plus root 5 all over 5 take away root 5? It also turns out the fifth Fibonacci number is 5 itself. Surely now you realize the relation of 5 and phi. Unfortunately though, this brings us to the end of the video. I really appreciate you watching. Please like and subscribe as it helps a lot. In the next video, we'll be viewing the basics of complex numbers. See you then!